Hello students, how are you? I hope you are doing well. Today I have come with questions from general properties of matter, heat and waves. These questions have been picked from the second session or the afternoon session of 29th January 2023 JEE mains. So let us discuss them one by one. So here comes the first question. As you can see, a fully loaded Boeing aircraft has a mass of this much. Mass of the aircraft is given. Total area is also given. It is in a level flight. Level flight means moving with horizontal velocity with a speed of this much. Speed is given, density of air is given, the fractional increase in the speed of the air on the upper surface of the wing related to the lower surface. So here as you can see that the there has to be a pressure at the down more than the pressure at the top. Only then the Boeing aircraft will get lifted up. So P1 has to be greater than P2. So automatically the air which is flowing in the opposite direction, here the velocity should be less and here the velocity should be more. So they are asking the fractional increase in speed on the upper surface related to the lower surface. This is what they are asking. This is what they are asking. So this could be calculated in this way. Okay. Now we'll apply Bernoulli's theorem for horizontal flow. Bernoulli's theorem for horizontal flow is this: half rho v square plus p is equal to constant. This is a Bernoulli's theorem for horizontal flow. So for these two sections up and down, we can write half rho v1 square plus p1 is equal to half rho v2 square plus p2, or we can write p1 minus p2 is equal to half rho into v2 square minus v1 square. So this pressure difference should be adequate enough to raise the Boeing aircraft, because you can see the Boeing aircraft has been the weight of the thing has been given, mass into g. So based on the weight and its area, you can find the pressure required. So the pressure required will be to lift the Boeing aircraft is this. That is the required pressure. Now this can be written as V2 minus V1 into V2 plus V1. A small approximation will do, that I'll let you know. So M is given as 54 into 10 to the power 4, to G is 10 of course. Area is 500 meters square given. I am substituting all the things in SI unit, so no need to worry about the units. Half rho is 1.2, and if we can find V2 minus V1, we'll do one thing students. Here we'll take this average velocity between the upper and lower wings to be equal to the speed of the flight, that is 1080 kilometer. So 1080 kilometer to be converted into meters per second. Okay. Then so here we will be getting two zeros gets cancelled here. 5420 is then V2 minus V1, 6 2 is 18, 6 2 is 12, 6 3 is 18. So this will be V2 minus V1 will be, this 3 will go up, 3 into 10 to the power 4 upon 5 2 is 10, we have 200 into 5. This 5 is there, this 5 is also there, 10, yes. So this will be 300 upon 10, that is 30. So the required fractional increase is approximately V2 minus V1 by V1, which is V2 by V1 minus 1. So V2 minus V1 is 30. Here, the speed of the air at the lower wing can be taken as equal to the speed of the aircraft itself, which is what we got. This will be 300. So this 1 by 10. Since we have to calculate the fractional increase in speed in terms of percentage multiplied by 100. So when you multiply 1 by 10 by 100, so the required value is 10. So I hope that is clear. Moving on to the next question. A metal block of base area this much is placed on a table as shown in figure. A liquid film of thickness this much, this thickness is given, is inserted between the block and the table. The block is pushed by a force of this and with a constant speed. If the viscosity of the liquid is this much poissually, then the speed of the block is. Now students, this is simply based on viscous force is numerically equal to A delta into delta V by delta L. Now here this liquid film, we should know the value of delta L which is given, and if the block moves with a velocity V, then this will move with the velocity V, whereas the lower layers will be almost at rest. So that means you will have eta A V by delta L. Now since the block moves with constant speed, it is clearly mentioned that the block moves with constant speed. That means what? The external force is just able to manipulate the or balance the viscous force. When the external force is equal and opposite to the viscous force, the block will not gain any kinetic energy, neither will it lose kinetic energy, and it will keep on going with the constant speed. So this force is nothing but the externally applied force. So we have to substitute the values, that's it. So this is 0.1, I am writing it as 1 by 10. Eta is given as 5 into 10 power minus 3. So 5 into 10 power minus 3, I have written like this. Cross section area is also given as how much? 0.2, I will write it as 1 by 5. And distance, that is the length, is 0.25 mm. 0.25 is 1 by 4 millimeter. Milli means 10 power minus 3. Then 10 power minus 3, 10 power minus 3 gets cancelled, 5 gets cancelled. Then we are left with this 4 goes up and it comes down. So 1 by 10, this 4 goes up and straight away here. So 1 by 40. Since we have to express in 10 power minus 3, multiply and divide by 10 power minus 3. So when we multiply and divide by 10 power minus 3, let us multiply by 10 power 3 and also divide by 10 power 3. So 40, 25. So correct answer is 25. Okay. Then let us move to the next question. At 300 Kelvin, the RMS speed of oxygen molecules is this much times that of the average speed in the gas. Then the value of it. Now, first of all, students, you have to understand that it has nothing to do with the temperature. Temperature is redundant. That is, it has nothing to do with the solution. Now, RMS speed of a gas molecule is equal to under root R 3 RT by M, and similarly average speed is equal to under root 8 by pi RT by M. You have to remember this, students. And also, even though it is not asked, most probable velocity will be under root, instead of 3 you have to write 2 RT by M. These things are supposed to be memorized, students, because very often they keep on asking these questions. Okay, so you need to memorize them. So here we are interested in these two things. So it has been given that vrms is this much times of v average. In other words, vrms is some under root alpha plus 5 whole divided by alpha times of v average. That is what is given to us in the question. So when you write down the when you substitute the corresponding parameters there, so you get something like this. Okay, so you can square both sides. Squaring both sides, you will be able to eliminate the square root symbol there. Once the square root symbol gets eliminated, you can simplify this. They have asked you to take pi as 22 by 7. So let us take pi as 22 by 7. So this will be 3 is equal to alpha plus 5 by alpha into 8 upon 22 by 7. So we can cancel 2 4s and 2 11s. So this will go up. So 33 by 28 is equal to alpha plus 5 by alpha. Okay, so this can be written as 28 plus 5 whole divided by 28. So comparing these two, it is easy to see that alpha is 28. Then moving on to the next question, heat energy of this much is given to ice of mass this much at minus 12 degrees Celsius. Specific heat of ice is this much and latent heat of ice is this much. Now they are given different conditions there. We have to check for the correct condition. Now a small piece of advice, students, kindly these kind of questions don't straight away jump into solving the question, because you will lose a lot of time. In fact, these questions are meant to meant to waste your time there. So if you simply jump on to solve these kind of questions, you will waste a lot of time. First thing. Second thing, there is no guarantee that you will get the correct answer. So one loss will be you have already lost your precious time, which you could have invested in solving other questions, which were much more easier than these, and in which you could have got correct answers. The second loss is that you will not get the answer also, because a lot of calculations will be involved. So either you discard these kind of questions, just leave them. If you are running short of time and all, just leave them. Okay. Instead, focus on those questions which are more easier and more simple to solve than these. But if at all you want to solve these kind of questions, then make sure that you apply a certain kind of shortcut technique, which I am about to teach you. In fact, it's not shortcut technique, but basically it is an approach, a way which will drastically reduce the time of solving this problem. Okay, so without wasting time, let us start this. The first thing what I am going to do is that I'll be handling the data in terms of calories. Okay, I don't want to use this data in terms of joule and all, because a lot of big numbers are coming. So I know specific heat capacity of ice is around half calorie per gram degree Celsius. Also, latent heat of fusion for ice, specific latent heat of fusion for ice is around 80 calories per gram. By means of these two, I'll be able to solve a lot of time. The second technique which I am going to use is this. Instead of 600 gram, because see, the heat given is in kilo. So let us reduce the entire situation by a factor of 1000. That is, we are dividing all the quantities by a factor of 1000. I hope you are getting my point. So the situation will not change. That is what I mean to say is that suppose, as an example, I'm telling 1 kg of a substance, you are giving 1,000 calories to 1 kg of a substance. That is equivalent to saying that you are giving 1 calorie to 1 gram. Instead of giving 1,000 calories of heat to 1,000 kg, you are giving 1 calorie heat to 1 gram. So that is equivalent. So I'll be reducing the parameters to 1,000th of the given values. That means this I'll take it as this much itself, 184 joule, which I'll convert into calories. Roughly I'll get it as somewhere around 45 calories or something roughly. And this I'll take it as zero point 0.6 gram. That's what, zero point 0.6 gram. I had divided by 1,000. So the situation is zero point 0.6 gram of ice at minus 12 degrees Celsius has been given this much amount of heat, and then we should be in a position to predict what will be the consequence there. Now, since you can see ice is already at a temperature well below its melting point, so first of all, ice will gain heat and its temperature will rise from minus 5 to its melting point, that is 0 degrees Celsius. So let us first calculate the amount of heat required for ice to get raised its temperature from minus 12 to 0. So I'll be using the formula ms delta theta. So mass is zero point 0.6, specific heat capacity is 1 calorie per gram degree Celsius. Rise in temperature is minus 12 to 0. So this will be 2, 3, so approximately it is 3.6 calories. Now, the amount of heat given is 45 calories. So if it will take around 3.6 calories of heat, and then now the temperature of ice will become 0 degrees Celsius. And 45 minus 3.6, around 41.4 calories of heat are still left there approximately. Now what happens if still heat is supplied to the ice? It will start melting. Now let us calculate what is the total amount of heat required for the complete ice to melt. So total amount of ice is 0.6 gram and heat required is 80 calories. So around 48 calories of heat will be required. 48 calories of heat will be required. Whereas what is the amount of heat available? Roughly around 40. Okay. So that means most of the ice will melt because the requirement is 48 and it's already getting around 41 or 42. So around 5 parts of the ice will melt and only 1 part of the ice will be left as it is. So since 5 parts of ice would have already melted, it would have got converted into water. So final mixture is 1 part of water, sorry, 5 parts of water and 1 part of ice, and the final temperature will be 0 degrees Celsius. No more heat transaction, and it will come to a standstill. That is, it will comes to a stop. So let us conclude the things. Final temperature of the system will be 0 degrees Celsius. That is true, and the final system will have a mixture of, as you know, that almost almost 50, most of the ice has already melted, so it would have got converted into ice. So ratio of water will be more and ratio of unmalted ice will be less. So A and D are the correct options. So if you attempt this way, you'll be able to save a lot of time. Moving on to the next question. A particle of mass 250 gram executes SHM under the periodic force of this much. The particle attains a maximum speed of 4 meters per second, amplitude of motion. Now students, you know that the speed of the particle at any instant at a position x is given by this, where x is the instantaneous position or displacement from the mean position. This is the mean position of the particle undergoing SHM. Now, in order to have maximum speed, x should be minimum, and that minimum x will be 0 when it is at the mean position. So always remember, when a particle crosses the mean position, it will have maximum speed, and that maximum speed is this. So if we can find omega and v is already given, then we can find a. How to find omega? Now the standard form of simple harmonic motion is a equal to omega square into x. Here force and mass are known to us, so we can find the acceleration as force by mass. So force is how much? Force is minus 25x and mass is 1 by 4th of kg. Remember, gram has to be converted into kg. So we have a equal to minus 100x. So comparing these two, we can see omega square is 100, so omega will be 10. So now let us substitute the values here. The maximum speed is 4 meters per second, so 4 meters per second. Omega we got as 10 into a. So a is equal to 4 by 10. Since we have substituted everything in SI unit, we can expect the answer in meters. Since we have to calculate in centimeters, multiply it by 100. So when you multiply it by 100, you will be getting 40 cm. So 40 is the answer. Then that's all in this video. Thank you for watching my channel. Thank you so much.